Alrighty, folks, we are going to have a look here at these two SN1, SN2 reactions here, nucleophilic substitutions. We're going to start with the one on the left, chlorobutane with sodium hydroxide. Let's first of all have a look at those two molecules. Okay, so there is 1-chlorobutane. It is a primary halogenoalkane, and the carbon here, okay, has two hydrogens on it, a chlorine, and then those other three carbons are attached to it as well. And those are the three things, or the four things rather, attached to that carbon. So here they are again, two hydrogens, one chlorine, and those three carbons there are all attached to that one carbon. So let's draw it a little bit differently. Okay, and there it is there. And just to kind of point things out, this carbon here is this guy right there. There is the three carbons. Obviously, there's my Cl, and the two hydrogens are down below here. Also note that this carbon right there is attached to one other carbon. That's it. It's also attached to a hydrogen, and a chlorine, but only one other carbon, making that a primary halogenoalkane, which tells us this proceeds by the SN2 mechanism. Okay? And in SN2, we know that the first thing to happen is a nucleophile attacks. Okay, so my nucleophile is a hydroxide ion, okay, and it is going to attack from the backside away from this chlorine, because this chlorine has a giant electron cloud, 17 electrons big, okay, versus only one electron in both of the hydrogens there. So there is less steric hindrance on the backside of that molecule. So the nucleophile attacks, and we show that with what's called the curly arrow, which is an arrow showing the movement of a pair of electrons. It looks something like this. So I circle one pair of electrons to just show what's moving, and I draw, you don't need to draw the circle, I suppose, but there's my curly arrow. In other words, it's not a straight line, it's a nice curly arrow. You could even make it extra curly if you wanted to. Woo! Okay? Showing that those electrons are attaching itself to that carbon, which makes my unstable reaction intermediate, which has a five-membered carbon negative ion. It looks like this. Okay, there's my unstable transition species with five different things bonded to that central carbon. Okay, so this is not very stable. It's just in the transitional state. If you watch that SN2 animation again, okay, you'll see that same thing happen, and it just briefly exists. And then what happens, what we have to show happen, is that these two electrons kick out onto that chloride or chlorine atom, making a chloride ion, and then everything else kind of flops over to the other side. So that's going to be my third drawing here. I'll draw it down below here. Okay, so just imagine that everything else is going to keep pushing to the right there, with the hydroxide on the left, and the chloride gets kicked out. So there is my carbon with the hydroxide there. The chloride is out here somewhere with all of its electrons or whatever. You don't need to worry about drawing electrons right now. That'll all make sense later in chapter 4. Just trying to be accurate. And then the other two things are going to be drawn, well, they're pushed out more, so they're now facing the other way, like this. Kind of instead of pointing down to the left, now they're pointing to the right. And then that 3-carbon CH2, CH2, CH3 thing is also pointing to the right now, or it's on to the right-hand side. Okay? And the actual shape of it will become more important again in later chapters, but I'm just telling you that's how you do it. Okay? So those three drawings are what you would have to show for a mechanism, okay, for this reaction. You're going to show your original species for SN2, which is that first drawing I did in black there. You have to show the nucleophile coming in with the curly arrows, okay? This intermediate species is a 5-membered ring. You have to be able to show that as well, and then show the curly arrow, these two electrons there moving onto the chlorine, and then your final product, which is your primary alcohol, butane 1-ol, and if you want, you can also show the chloride ion taking off as well, okay, like I've done there. So those three things are required for you to be able to draw. So seeing that, I'm going to stop the video here and make another one, which is going to show the SN1 mechanism for this other reaction here. So in between watching this video and the next one, why don't you see if you can come up with that on your own? The only difference is the steps happen in reverse. the halogen leaves, and then the nucleophile attacks. Give it a try.